Right, so with this question, we're looking at what this formula could represent, whether they represent length, area, volume, or actually none at all. And if we take this here, for instance, right, I hope you can see that this would represent an area, okay, because it's like d squared, d times d, okay. So for area, I'm going to just call it L squared, right, because area is like length squared, isn't it? Here, you've got HW, haven't you? H times W, though. H times W. So that again gives me another area, because H times W represents an area, maybe a rectangle. So area and an area produces an even bigger area. Okay, so we can write that there. D plus W plus H. Well, D is just a length, isn't it? W is just a length. H is just a length. So what happens when we add three lengths together? Well, we just get an even bigger length. Okay, so it's still a length. Here, now pi is just constant. Remember we learned pi is like 3.14, yeah? Because that's what it is. So don't think of pi as a letter, it isn't. And again, you've got a constant here, 2, right? What it's doing is it's just making the whole thing bigger, right? When you've got 2 in front of it. So it's doubling it, isn't it? It's not making much of a difference. The R is the important bit here, because the R represents length, doesn't it? Yeah, that makes sense. R represents length. But having 2 pi in front of it just makes it bigger. You're multiplying it. Right? So it's not really that important. We're taking away then this. You've got pi r squared. Now pi, remember, is a constant. 3.14 is not important. R squared. What does that represent? R squared. R times R. It represents area, doesn't it? Like area of a square, for instance. So we've got a length taking away an area. Well, that shouldn't make any sense. You don't do that, don't you? Length take away area. It just doesn't make any sense at all. So it can't represent any of them. So you just say none, right? None of them. In here now we've got a bracket, right? So we've got D plus H, right? Now D plus H is like a length, isn't it? There, D is a length, plus then H, another length, okay? And then you close the bracket and you're timesing it then by W, which is another length, okay? Let's look at what we got in this bracket. L plus L is just 2L, isn't it? Yeah? You can just make that to be 2L. And then, of course, you're timesing it by the L outside the bracket. So you get, what you get, 2L squared. Yeah, 2L squared. Well, L squared, we know, represents area, doesn't it? The fact there's 2 in front doesn't make any difference. Just makes it bigger still. But it's an area, L squared. Last one then, D cubed. Well, D cubed is going to be volume, isn't it? Because it's D times D times D. So we've got like a volume there. Okay, so we'll call it L cubed for volume. Plus then, what have I got here? D times W times H, okay? Well, that's like doing length times length times length, isn't it? Length times length times length. And length times length times length is just L cubed, isn't it? So I've got L cubed plus another L cubed. Well, if I add L cubed and L cubed, I just get 2L cubed, don't I? Remember, L cubed represents a volume, so doubling it, I get an even bigger volume.